Okay, I want to talk a little bit about CMU walls, and that stands for Concrete Masonry Unit. Cinder blocks is kind of the most common name for them. We don't really have a tradition of CMU walls in this area, and the reason being is that we have plentiful timber resources. If you go to places where they've either cut all their trees down already or they don't really have like trees that can be harvested and turned into lumber products, then you see a lot of CMU walls. Anybody can make cement. Anybody can get sand and gravel and turn it into concrete and make concrete masonry units out of it. And you can build a very durable house out of these materials, okay? Not my favorite look, but it certainly has its place. So some people use these as the foundation, okay, instead of setting up form boards. So let me back up a little bit. Some people build entire buildings out of these things, okay? And we have a few of those around here, but it's more common to see these used as the perimeter foundation. And I think there was a time in the 80s, early 90s when the CR program used this style of foundation, okay? And so this is I guess where it makes sense. If you're going to build one house, it's not really in your interest to buy form boards and set them up and pour concrete, and then what do you do with the form boards? Maybe you can use them for the floor or something like that, but it might make more sense to just buy a bunch of blocks and put them in it and be done with it, okay? So you could build your perimeter foundation out of this. And what you would do is you would pour the footing, just like with the snap tie walls, you would pour the footing first. You would have some rebar, vertical rebar, sticking up out of the ground. You would set blocks over that rebar. You'd have to plan out the rebar so that the rebar landed in these cavities, okay? They're called cells. And so usually these blocks are 8 by 8 by 16. 8 inches wide, 8 inches tall, 16 inches long, and then there's like an inch and a half, inch and a quarter rim around it, and then the interior is hollow. So this block slips over the rebar, and then what you would do is, you slip a course of blocks over it, put some horizontal rebar in every couple courses of block, and then once you get up to the top, you would fill all these cells again with concrete, okay? There'd be mortar that would go on the joints. There's a name. This is like the head joint, and this is the bed joint or something like that. I can't remember exactly what it is, but there would be mortar in these joints, and then you would fill this with concrete, okay? Again, there's not really a tradition of this around here, but some people are really into this. There's a cool video. I really appreciate the skills. And then so this is falling more into the field of like masonry, okay, more so than a carpenter. If I were to take one of these projects on, I could maybe pull it off, but I don't have a whole lot of experience doing this. This is more in the realm of masonry. Okay, this video is pretty awesome. We should watch this.
Building a block wall. Building a concrete block wall is one of the more involved building projects, requiring careful planning and a little heavy lifting. But regardless of your skill level, a successful result can be achieved. Every block wall, regardless of whether it is going to be a structural wall or a non-structural wall, requires a solid footing. High-strength Quikrete 5000 is the recommended product for footing construction because of its high strength and rapid strength gain. Footing should be at a minimum of twice the width of the concrete block. A typical 8 by 8 by 16 block would require a 16-inch wide footing. The footing depth should extend below the frost line. Make sure to check local building codes for construction requirements in your area. Snap a chalk line on each side of the block wall as a reference line. Quikrete Mason Mix Type S is the recommended mortar mix for constructing structural and non-structural block and brick wall. This pre-blended mortar mix is extremely workable and achieves the high bond strengths required for a successful project. One 80-pound bag of mason mix will lay up to 13 standard concrete block. When preparing to place a trowel full of mortar, gently snap the trowel downward to remove any excess mortar. The proper consistency is achieved when the wet mortar will hang on a trowel held at a 90-degree angle. Dampen the footing surface with water and place a 1-inch bed of mortar on the footing. The mortar should be workable, but firm enough to support the weight of the block. Press the first block, the corner block, into the mortar bed to create a 3/8-inch mortar joint. Make sure the block is level and properly aligned before proceeding to the next block. Then trim and remove any excess mortar. Using the same process, set the opposite corner block. Butter one end of the block and set it next to the corner block. Then press the block down into the mortar bed and against the previously laid block so that the mortar joint is 3/8 wide. Adjust the block so that it is flush and level. Continue this process until the first course is completed. To start the second course, apply a thick mortar bed along the top of the first course. At the end of the wall, set an 8x8x8 half block into the mortar bed with a smooth side facing out. This process will create a very strong running bond pattern that ties the wall together. Use a mason line as a guide for the remaining block. Continue building the wall until it is complete. Once the mortar joint has become thumbprint hard, use a joining tool to smooth the fresh joints and remove any excess mortar. For load-bearing walls, tie rods should be set a minimum of 6 inches into the concrete footing before it is set. Rebar should be placed in every other masonry core to provide structural support. For masonry cores over 4 inches wide, as is common with standard 8x8x16 block, Quikrete core-fill grout cores should be poured around the rebar. For masonry cores under 4 inches wide, Quikrete core-fill grout fine should be used.
Okay, so that was very much, well, first of all, respect to the masons. Those were some mad masonry skills. Very impressive. But this was very much like building a garden wall or something like that. If we were building a foundation or an entire house, there would be a more substantial footing. There would be rebar cast into that footing, and it would be built from there. So when we do our foundation, we're going to put vents in the foundation. There is the potential for moisture to accumulate underneath the foundation. And again, this is only if we're doing a crawl space foundation. If we're doing a slab, there's nothing under the foundation. It's just concrete, so we don't have to vent anything. But if we're doing a crawl space foundation, we should add vents unless we're going to condition the crawl space. Okay, so there's two schools of thought with this, and the kind of avant-garde building science school of thought is that you should not vent underneath the house, okay? Because as much as we're trying to give moisture a way to get out, it can also provide a way for moisture to get in underneath the house, okay? So we could close that off completely, but then we would have to probably pour a slab on the ground, okay? So there wouldn't be any way for moisture to wick up from the ground. And we'd also have to condition that crawl space. And what that means is we would have to run a duct, okay? Either for the heater or the air conditioner or both. And so we're actually sending conditioned air underneath the house, okay? Because what can happen if it's really cold underneath the house and we have warm air, warm, moist air traveling underneath the foundation? If it hits a cold surface, it will condense and will turn back into liquid water. And we could have water building up underneath the house. So if we condition it, we're not going to have that problem. Okay, so I was starting to see this a couple years ago, people not conditioning or not venting underneath their perimeter foundations. And I thought, oh my gosh, are we supposed to be doing this? And so I talked to some building science professionals that I was at a conference with. And I was like, oh, what do you think about this, unvented crawl space. And the guy was like, oh, absolutely. You should do that all the time, no matter what. It's the best way to go. And I said, nobody does it where I'm from. And he's like, oh, where are you from? Oh, Northern California, right on the ocean. He's like, oh, we'll just vent it then. Don't worry about it. Okay, so a lot of these things are very, very climate specific. And our climate doesn't see a huge temperature differential. It doesn't see huge humidity swings. We are in a pretty good building climate, and we're going to talk a lot more about this, but at any rate, don't worry about conditioned crawl spaces. We're just going to vent it. And so there's this rule of thumb that for every 150 square feet of underfloor space, you need 1 square foot of ventilation. Okay, so you have to know how many square feet these vents represent. Okay, and calculate how many vents you need to put in to meet that 1 square foot of ventilation per 150 square feet of underfloor space. Okay. The other kind of general rule is we want to vent 3 feet off the corner. Okay, corners can tend to be kind of dead zones where there's not a lot of airflow. So we want to get vents close to those corners. And we're not going to use a vent like this. It's not going to be metal grate. The vents that we use are plastic vents that get cast in place, and they're sized according to our stem wall. So they're 8 inches wide, and we nail them into the forms, and concrete gets poured around them, and then when we pull the form boards off, the vent stays in place. Okay. The other thing that we want to keep in mind is that wherever we put a vent, we want to have a vent across from that, okay, on the other side of the house in line with it. And what that does is it allows for cross ventilation. Okay, it's just like when you open up a door, open up your front door, and if your back door lines up with it and you open that up, all of a sudden you have a wind tunnel. Okay, same thing with windows. If you open up a window and directly across from that you open up another window, there's a lot of air moving across. Okay, if those vents aren't lined up, you're not going to be able to maximize your ventilation. Okay, we want those vents to be placed kind of higher up towards the subfloor, because what we're trying to do is we're trying to vent underneath the floor. Okay, we're trying to vent the joists, we're trying to vent the subfloor, we're trying to dry those things out. Okay, if it's down low, it doesn't do us any good to just be blowing air across the dirt. Okay, we want to be removing moisture that might have a tendency to accumulate underneath the wood, and that could lead to wood decay. Okay, we need to be really careful around the gas meter. Okay, if we're having gas installed at the house, which we normally would do, we can't have a vent near the gas meter because there's a concern that it could be drawing gas. As that gas meter vents natural gas, it could be drawing it under the house, and there could be problems with that. Okay. So to kind of wrap this all up, after we've set up all of our forms, we want to double check all the legs. We want to verify our lengths. We want to double check the diagonals and make sure that we're square. We want to double check the elevations. We're going to go around with a laser and make sure that everything is within an 1/8 of an inch, something like that. Okay, we want it to be pretty darn level, pretty darn flat. And just remember that, like I said before, we want to start out as perfect as we possibly can with this foundation, because things are going to get messed up as we build up. Okay, errors are going to compound. If we can start out flat and square, and then little mistakes happen and things get out of whack as we go, it won't be as bad once we get up to the top. But if we start out already out of level and then start building in all these mistakes, it's going to be kind of a nightmare once we get up to the top. So lots of double checking, lots of verification when we're doing this. Okay. Thanks, everybody. Please send me emails with any questions that you might have, and I hope you enjoyed this video.